Hey, so today is a lecture just before the reading week. So remember, after the reading week, only after 1 week, we're going to have lab test 2. So I'll release the guide for lab test 2 to you very soon. So you do have enough time to get them prepared for lab test 2. Lab test 2 is just about loops. Okay? So basically whatever you have done so far in the lectures and also in the lab exercises. Let's again continue with our new example. Okay? This one here, let's do it as a warm-up for today. Okay? Let's say we have an array of names of strings. Okay, so now we try to deal with strings rather than integer. Okay, just a simple example. How do you print the contents of the names as comma-separated list? So this is very similar to what you have to do for your lab number 3. So if you have already figured out, good, but let's see if this might match how you solve the problem. Okay, let's just see one example over here, and then we'll look at the code. There's only one minor detail I want to mention to you in the code. Let's say if you simply have an array of string, you got Alan, Mark, and Tom. So this is what you want to print out. You want to say names, colon, followed by a space, and then Alan, followed by comma, Mark, followed by comma, and then Tom. Notice that the last element in the array should not follow another comma, right? Comma is only in between the elements. So now, how do we solve this problem here? Okay, let me show you the solution directly because there's one minor detail I want to point out, okay, which is worth noting. So this is the solution over here, okay, about a comma-separated list. And we have, let's say we are given this particular array over here, names, which is of size 3 at the moment, right? So now let's try to see how we can solve this. First of all, you can see outside the loop, we simply just print out something that does not have to be repeated. So simply in the console, we simply print out names, followed by colon. Okay, so that's what we have got so far. And then we're going to run the loop. You can see the way we run the loop over here is just standard. Starting with index 0 until the strictly less than names.length, which will go up to including names.length minus 1, and then I++. Everything is good over here. The only line I want to draw your attention to is the following line. If you pay attention to this particular line over here, I say, I will only print out the comma over here if the current value for I is strictly less than names.length minus 1. Okay? So that's the condition I want you to pay attention to. That's the only thing that's worth learning about from this example up to now. Okay? And then after the loop, we simply just say we want to print out a period over here. Okay, it's a period. So that means at the end, we're going to have a period. But what about in between? What do you mean? A little bit bigger? So maybe it's too small? So are you missing any? Oh, you mean you're missing some? You mean the code here? You want to make it bigger? Okay, I can do it. Would that be okay? I'll try, but yeah, try to see. Usually I also try to read out, the important part. So try, yeah. It's kind of hard for me to move around, but I'll try my best. Okay. If that's too small, just let me know. I'll try to make it larger. Okay, good. Okay. So now let's have a look at this particular line. Let's think logically. Okay. In this case, we know that names.length for this particular array is simply 3. Agree? Okay. We are saying that as long as I value is strictly less than 3 minus 1, which means it's strictly less than 2 in this case. So what can be the value for I in this case? It can be 0, it can be 1, right? 0 and 1 are going to make this particular if condition, branch condition true, okay? So which means it's going to make 0 and then 1 true, okay? So how does that turn out to be the tracing? Let's go very quickly. Initially, I is just going to be 0. So I is going to be 0. 0 less than names.length would just be 3 in this case, so that'll be true. Not a problem. Okay? I can even predict later on it's going to be 1, and then 1 less than 3 is going to be true, and also 2 less than 3 is also going to be true, and also eventually 3 less than 3 is just going to be false. We pretty much know that. Okay? But the interesting bit really is this part over here. Okay? Let's try. Over here, in the case where you can see we always, as a body of the loop, we simply just print out the names unconditionally first. And then we decide whether or not to print out the comma. Okay, that's what we do. In the very first iteration, I is simply just 0. So names at position 0 will just be Alan. Okay, so that means we're going to print out Alan over here. Okay, we're going to simply execute this line here to print out Alan. What about this condition over here? So now at the moment, I is simply just 0. And then so we are checking 0 less than, as we just calculated, names.length minus 1. 0 less than 2 is going to be true. So what does that mean? That means we have to go inside the body of the if branch and then execute printing comma. Okay, so after that we have a comma. Okay, that's what's achieved in the first iteration. You can imagine we're going to do the same for the second iteration until in the last iteration we should not print out a comma. That is why. Okay, let's do that very quickly. Okay, now let's try another one. So now when i's value is 1 in the second iteration, then so now names at position I is simply just going to be Mark. Okay, if it is Mark, and now we have 1 less than 2. So we are checking this if condition again. That is going to be true. So that means we're going to print out Mark followed by comma. So far so good. Okay, here comes the critical point. So now so far we are still fine. We are not reaching the last element just yet. And now let's try one more. So if I try this, let me try to, let's say the value is incremented to 2 for the third iteration. Okay, so we still go into the loop. So now we're executing this for the third time. In that case, what's names at position 2? It's simply just going to be Tom. So that means we're still going to print out Tom. However, we should not print out comma anymore, right? That's the critical point. Because it's comma separated, so only comma should not follow the last elements. In that case, if we try to check this if condition again, over here, I less than, I in this case is 2. 2 less than names.length, which is 3 minus 1, 2 less than 2 will give you false. So that means we're going to bypass the body of this if statement. Okay? So that means that's it. Only print out Tom without a comma. Okay? You can do similar style of programming for your lab. Okay? For future lab as well. It's very convenient. Again, as I said, maybe recap very quickly. The only thing you want to really pay attention to is what is the logic for this particular line, for the if statements. If you simply don't have this if condition over here, what you will have is Alan followed by comma, Mark followed by comma, and then Tom followed by comma. That's not what we want. We want to get rid of the ending comma. That's why we got an if condition.
If we go writing print and point instead of print line, what would happen?
So basically, so you're basically asking about the difference between print versus print line. So just very quickly, because we did cover that in elementary programming. When you say print line, it's as if you say print followed by a new line character. So you go to the next line. Okay, you can experiment with that. Okay. All right. Any question for this example here? Comma separated list. Okay. Okay. Let's go to the next example. Okay. This one is done. Okay. So now, this part here, we already talked about how you can go through the array using either a for loop or while loop, right? This one we already talked about, so I'm going to just go let you read it. Okay, so now let's do another simple one, and then we go to the more tricky one for today. So let's read the problem together. Given an integer array, we got an array of integers. Integers value can be positive, or can be 0, or can be negative. Let's say we want to print out positive numbers only. Okay, it's a very easy combination between the for loop and also if statements. Let's see how we can do that. Okay, for example, in this particular array, what should we print out? We should print out 2, 1, 3, 4, and we'll skip minus 4, and then 10. That's what we should do. Okay, let's have a look at the solution quickly, and then we'll go trace the code all together. This is very similar to the comma separated list problem we just saw previously. Okay, very similar. Basically, you have a for loop, and over here, the way you initialize the loop counter, and also state condition here, and also updates are just standard. So that means we want to go over every element from left to right. And now the question is, which one should we print out? This is why we actually got an if statement inside it as the body of the for loop. Every time when we are facing an element in the array, we want to know if it is positive, print it out. Otherwise, do nothing. Okay? Let's just try to trace it all together quickly. Let's say I got this particular array over here. So let's say we try this. Okay. So now for the very first iteration, I is going to be 0, right? 0 less than, so in this case, a dot length, the last index is 5, so the length is simply 6, right? 0 less than 6, which is true. So now ai is just going to be the first element, which is 2. In that case, what is the value for when we check this particular branching condition here? That means we are checking 2 larger than 0 over here, which is going to be true. That means we're going to print it out. We're going to print out the 2. Okay? I can tell you that it's going to be very similar for the next 1, 2, 3 iterations. When I is equal to 1, in that case, the element is simply just 1. So when we check this condition over here, 1 larger than 0 is going to give you true. So you also print it out. So we also print out 1. Similarly, when we reach the third iteration over here, I value is going to be 2. And then A2 is going to be 3. So 3 larger than 0 is also going to be true, right? So we also print it out. So 3 is also printed out. Third number. Okay, let's say this guy here, the fourth iteration. I value is simply 3. In that case, A3 is going to give you 4. And then we check this condition again. A at position 4, A at position 4 is simply just going to be 4. 4 larger than 0 is also going to be true, right? So far, so good. Now, here comes the critical point. When we reach the next iteration, I is going to be incremented from 3 to 4. So that means I is now 4. Okay? 4 less than length will just be true. We're still going to execute this particular branching condition here. Now, let's see what happened. A at position 4 is going to give you minus 4. That means when we check this condition over here, it's going to be minus 4 larger than 0, which will give you false, right? For this particular iteration. That means we are not going to execute the body of this particular if branch. We skip. Okay? So minus 4 does not get printed out. So that's why we say it's conditional printing. Finally, when we get to the next one, when I value goes from 4 to 5, so now 4 to 5, 5 is still less than 6, so we are still fine. Okay? What about the value at position 5? It's simply just going to be 10. And 10, when we check this condition over here, 10 is larger than 0, that is true, so we also print it out. Okay? So it turns out we're going to print out 2, 1, 3, 4, skip minus 4, and also 10. Okay, any questions? One moment, yeah. If you want to print out the, let's say, all the positive number in a way that's comma separated, you just follow what we did in the previous one, right? So if you want to, basically you're asking how can we combine kind of these two programs together? What you have to do is like something like this. So you're going to need 2 if statements. So that means this if statement here is figuring out whether or not to actually print out the number or not. In the case you have to print out the number, what you have to do is insert another if statement over here as part of the if over here. You want to say if the current I is less than, let me just check it, a dot length over here minus 1. If it is the case, I'm going to print the comma. Okay, that's what you can do. You can try it. It's a good question. Okay, the question really was, how can you somehow print out positive numbers only, and also all the numbers printed will be separated by comma?
The first line, can we add the AI greater than 0 to the condition by putting it and?
Okay, yeah. Basically, the question is like this. It's kind of like a nice preview of what we're going to cover in just the next example. The question is as follows. Let's say the problem is the same. We want to print out the positive numbers only. Okay? The question goes like this. What happens if we extend this particular state condition over here? I'm going to write it here, okay? Extend it to the following. I less than a dot length. By the way, the state condition here, as I said, can be any Boolean expression. You definitely can use conjunction or disjunction, right? So now if I say ampersand, a at position I larger than 0. That's what you're asking, right? Okay, Let me just tell you verbally quickly, because I'm going to trace the code together with you in the example that's going to come. In this case, the truthfulness for this state condition here depends on this has to be true, and also this has to be true as well, right? As long as one of them becomes false, the state condition becomes false, you exit from the loop. In this particular example here, as soon as you reach the 5th iteration, and then A at position 4 is simply just -4. In that case, A4 larger than 0 is going to be false. That means we exit from the loop right away. So we never get a chance to really try to print out 10. So that's not good for this particular purpose. Okay? So that's just a very quick preview of what we're going to cover in the next example. Okay? Any other questions about this example here? We okay? Okay, so now let's go on to, okay, and it's a very simple exercise for you. The version I gave to you for the solution is using a for loop. How can you write it equivalently using a while loop? Think about it, okay? Try it. Okay, actually let's do one more example and then we'll get to the one you just talked about, okay? So now, this example is more challenging than before, okay? Let's think about it. So, given an array, you can assume the array is simply not empty. It contains at least one integer, okay? So index 0 is always valid. Given an array, for example, 2, 1, 3, 4, -4, 10. It can be positive, negative, or 0. Doesn't matter. There's no constraint on that. You want to find out the maximum number in the array, okay? Conceptually, what should be the answer for this particular array? Just 10, right? 10 is the maximum, okay? So now, how do we do this in a loop? Okay, I would like you to think about just for 20 seconds. Okay, I can give you a little bit hints. You definitely need a loop to go over from the leftmost to the rightmost elements in the array as very standard. However, inside the array, you might need some if statement to help you. Eventually, you may, well, let's say this. You also have a variable called maximum, which is going to store the final result you want to print out. Let's say it's called the maximum. Okay? And the maximum value has to be somehow updated as you go through the array. That's kind of the idea. Okay? Think about it for just maybe 10 or 20 seconds, and I'll show you the solution. It's also a very common problem we have to solve. You can find a you can find a maximum, you can find a minimum, or you can even find a second maximum. Okay? Just using a loop. Okay? So now let's go over the solution. The solution goes like this. Very simple loop to write. Okay, you can see the code itself is very simple. But let's understand the logic. And then I will introduce some changes to the loop and ask you what's going to happen. Okay, so let's spend quite a bit of time discussing this. So now this is what we do. Conceptually, you can think about it like this. Let me just go conceptually before I trace the loop. Let's say we have some maximum value over here. Initially, let's say since we're going to go from left to right in the array, left to right, right? So now let's say the follows. I would simply say, let's say assume initially the first element is simply just the maximum. Just that, just assume. I will only have to reassign the maximum to another value if the current element I'm looking at in the array is strictly larger than that. That means I have to update the maximum. Think about this condition over here is really about conditional updates. Given the maximum so far, is the current element strictly larger than the maximum so far? If it is, I gotta update the maximum to the current elements. Okay? So now, if I go to the second iteration over here, the current element is simply 1. Should I update the maximum or not? In that case, no, because 1 is not strictly larger than 2. When I go to the third iteration, so now in this case, the current element I'm looking at is simply 3. 3 indeed is strictly larger than 2. So I have to update the maximum from 2 to 3. Similarly, when I go to the fourth iteration over here, 4 is strictly larger than 3. So I should update the maximum again. When I go to the fifth iteration, -4 is not strictly larger than 4. So I don't need to update that. Okay? However, when I go to the last iteration over here, 10 is indeed strictly larger than 4. So I'm going to update that to 10. Okay? Conceptually, that's how that goes. You simply focus on one element at a time, from left to right. Every time if the current element has to be updated to the maximum so far, you do it. Let's try to trace the code together. Okay? So now let's try that. So let me try to use pink. So now what we say is the first line of code is outside the loop. So we only do this once. We simply, let's assume A0 at position 0 is just going to be the maximum. A0 is exactly 2 over here, so maximum is initialized to be 2. No loop just yet. And then we're going to do this loop over here. Initially, I is just going to be 0. 0 less than the length of the array over here is simply just going to be 6, okay? 0 less than 6, and we know that it's true. So we have to go inside the if statement over here, check the branching condition. When we check it over here, notice that I'm saying AI. In this case, what's AI? AI is simply A0, okay? Larger than the maximum at the moment, which is 2, okay? What should be the value for this? Think about it. So A0 is simply just 2. 2 larger than 2 is going to be false. False simply means we don't have to go into this particular body of the if and execute it. We don't have to. We don't need to update, basically. Okay, false, and then we have to go to the next iteration. Let me use a different color. If we go to the next iteration, I will be incremented to 1. Okay? And then we're going to check this particular condition again. 1 less than 6 is also going to be true. And now we're going to check to see AI, which is A1. A1 larger than 2, right? The current maximum is still 2. So now what is the result? A1 is simply just 1 over here. So that means 1 larger than 2 is going to be false. Okay? A1 is simply just 1. So that means we don't update the maximum yet. Okay? Let's do one more. So now let's do, after this, we're going to increment the value of 1 into 2 for the I. So 2 less than 6, when we check this state condition over here, is going to be true. So we're going to check this condition for the third time. So what would that be? So basically, we're checking A at position I, which is 2. A2 larger than 2. A2 is exactly 3 over here. So that means this guy here is simply just 3. 3 larger than 2 is going to give you true. So this is the first time we have to update the maximum, which means we're going to execute this particular line over here. So that means we're going to execute maximum is simply reassigned to A at position 2, right? For this one here, okay? So now A2 is 3, so reassign that to 3. That's exactly how I read it through when I explained to you conceptually. Are we okay with this? Okay, good. I will, to save your time, I will leave it to you for the rest of the iteration, okay? The essence for this particular example is as follows. You have some variable over here outside the loop to initialize to be something. And then inside the loop, you want to say if certain condition occurs, I have to reassign that particular variable so that I can accumulate all the maximum, so far. Okay, that's kind of the idea. Okay, given this, I would like to suggest 2 possible changes to the loop, to the code. And we want to know whether the change is going to make the program still work or not work. Okay, change number 1. What if I change line number 1 over here, okay? Rather than saying maximum is A0, which is the first element, let's say I change that. I change that to be, what about if the maximum is simply just 0? That's the only change I make. That's the only change. Okay? So now, do you think the example, do you think that the loop is still going to work as before? It is supposed to find out the maximum regardless of the numbers stored in the array, which can be positive, negative, or 0. Okay? Intuitively, hopefully you might think that wouldn't work, right? Okay? The reason is very easy. What if the loop itself has negative values only? You can see we got -3, -4, and -1. In this case, do you ever get a chance? Well, since the maximum, if that's simply initialized to be 0 to begin with, do you ever get a chance to say AI, which is always negative, larger than 0? No, because negative larger than 0 is always false. So you never get a chance to update the maximum. So the maximum will just stay with 0. So what you're going to calculate after this particular loop is going to say maximum is simply just 0, which is not right. Okay? Conceptually, that's how you think about it. Let me trace it together with you. Okay? It's really important to understand this, this one here. Okay, let's try this one here together. Okay, let's say, again, the only change I made was to say maximum is simply initialized to be 0. So I put 0 over here, right? This line number 1. Now let's try the for loop over here. Okay, the first iteration, I is simply 0. And we're talking about this particular element over here, right? 0 less than, now the length of the array is simply just 3. 0 less than 3 is going to give you true, right? So now what's AI? AI is simply minus 3. So now, minus 3 larger than the maximum, which is 0, right? We're checking this condition over here. Is it going to give me true or false? False. That is going to be false. That means I'm going to bypass this particular body of the if statements. Okay? So the maximum remains to be 0. Let's try the second iteration. In the second iteration, I is going to be 1. 1 less than the length of the array is true. That means we still have to go to check this if statement here. So now what's AI? AI is A1, which is minus 4. And when we check this condition over here, AI is minus 4 larger than 0 is still going to give you false, which means we bypass this again. Okay, so that means maximum still remains to be 0. Okay, finally, if you try the last iteration, I is going to be incremented to 2. So now, counter value is still strictly less than the length of the array. Still true, that means we're going to execute the if statement for the third time. So now, what's the AI? AI is A2, which is minus 1. Now in this case, minus 1 larger than 0 is going to give you, again, false. So as I said before, as long as your array contains negative values only, you never get a chance to reassign the maximum. That's really the insight into why this version is wrong. Okay, so it's false, so we're going to bypass this particular part again. So eventually, maximum remains to be 0. So when you print out maximum is 0, it's simply wrong. So it's a logical error. Okay, any question about this discussion here? This discussion is very valuable because you want to know why just by modifying a single character in your program is going to make it stop working. Okay, it's really important. That's the change number 1 I want to discuss. What about change number 2? So change number 1 is going to make your program stop working. What about change number 2? Change number 2 over here, this is the change I would like to make. What if we change the initialization of the loop counter in line 2, okay, line 2 over here, rather than 0 over here, I'm simply going to put 1. Okay, what does that mean? That means if I want to figure out the maximum, rather than starting from the leftmost elements in the array, I'm going to start with the second elements of the array. That means that's basically what I'm trying to do. Okay, any idea? Should it still work or not work? No, actually, I'm saying just in general, array, right? Array can contain any elements. You can even actually use the example in the previous one. You can minus 3, minus 4, and minus 1. Doesn't matter. So my question is, given that the input can be any values, if I simply change the initial value for the loop counter to 1, is this still going to work? Okay? Let's think about it. Okay, if I simply try to trace this code very quickly, right? If I simply try to say the very first iteration, I'm going to have AI, which is going to be A1, right? A1 is just going to be minus 2. And what will be the initial value for maximum though? Remember, that's what's achieved in line number 1. We say maximum is simply A0. A0 is simply just 23. Okay? So now if you look at that, maximum is 23, and then the first iteration we are considering I being 1, right? The second element index. And then we say minus 2, okay, when we check this one here, okay? AI is A1, okay? So minus 2 larger than the maximum value, which is 23. In this case, we got false, right? So that means we're going to bypass this particular part of the if statements, right, for the first iteration. What about the second iteration? In the second iteration, we're going to have the increment from 1 to 2. In that case, of course, we can still go into the loop for the second time. So now for the if statement over here, what's A2? A2 is simply 46. And now we simply got 46 larger than the maximum currently, which is 23. Okay? In that case, it's going to give us true. That means we're going to update this guy here to be 46 because we're going to execute this line here, right? You're going to say max is simply assigned to A2. Okay, eventually we're going to say maximum is simply 46. It works. Okay? I want to really give you a very quick hint about why this is still working, even though we start with the second elements rather than the first elements. Okay? Let me give you 2 hints over here. Number 1, you can think about in this line over here, when we say maximum is simply A0 to begin with, you can think about conceptually, position 0 is already handled. Because it is already handled, we don't have to worry about it anymore in the loop, okay, conceptually. Second hint, if you just go back to the very original tracing over here, the version that works, I want you to look at this particular row, the very first row. Remember what we had over here for the very first iteration, the original version that works. If you look at the first row over here for the very first iteration, in that case over there, when we say I is initialized to be 0, right? So now that means when we try to really execute the if branching condition over here, what are we really checking over here? Think about it. I, for the very first iteration, is simply A at position 0. Larger than, what's maximum here? Maximum has just been initialized outside the loop before the first iteration, right? So that means maximum is also A0. So what we are really checking is A0 larger than itself, which is always false. Just false. Always. So which means this row here tells us the very first iteration always bypass the body of if statements. Simply because you're just comparing the same number over here. So that means, so that's redundant. So you can just ignore that for the first iteration. Okay, so given these 2 hints, we can simply say, rather than starting from 0, we can start from 1. Okay, that's the second change I would like to discuss. Okay, so these 2 changes are interesting to actually think about logically. Yes? AI plus 1 larger than max? I see what you mean. You're basically asking the following. Let me try that. Yeah, I see what you mean. Let me just copy this code over here to really make another page over here. Are you suggesting the following? You say rather than having AI, you want to say AI plus 1. Okay? Anyone want to give a comments to this? Any other change you would like to make? Okay? Guys, do you think this is okay? This could be a possible quiz question. I can simply give you this code and tell me what's going to be the console output, right? Are we going to successfully run this block of code without crashing? Okay, that's already a hint to you. Let me be more specific. Is there a possibility for us to run into array index out of bound exception? Is it possible? When? Right? Think about it. So I tell you what, every time when you are trying to use the index over here rather than just I, right? I is simply tell you starting from 0 until a the length minus 1. So these are the valid range of indices you can have. When you say I plus 1, be careful. Okay? So this is going to be not good because let's think about this. What's going to happen is as follows. In the last iteration, the value for I is simply just going to be a the length minus 1. Agree? That's the last index. Okay? And then when we do this expression over here, you're going to have a at position a dot length minus 1. This is the value for I. And then remember we got plus 1, right? And plus 1. And what's going to be this value over here? Well, it's simply a dot length. A dot length is simply not a valid index, so you're going to run into array index out of bound exception. Okay? It's a very good question. It's good to ask this. So let's say if you really run into this trouble, let's say in your lab exercises or lab test, you simply have no idea where it occurred. Your friend will be debugger, right? Try to run the loop and try to go step by step. You'll see exactly in the last iteration, you run into this trouble. It will compile. Remember, it's a very good question. That's really the tricky part about programming. Even though we say this code over here is logical error, logically speaking, logically incorrect. Even though it compiles. That is why I try to emphasize. Let me try to reiterate the point again. The tricky thing about programming is as follows. Usually, you can really get through the compilation error stage after the first 3 or 4 weeks, which we should be hopefully over up to this point. However, what's really problematic is you might run a piece of code that simply compiles, but just have subtle logical errors, like we keep emphasizing. That's why. Okay, that's why you need a debugger. Yeah. Okay, good. I like that. So we actually got more things to learn from this example. Okay, so now, let me see. I got about 10 minutes or so. Okay, so let me see the, what I would do is, I got 2 more examples for you. Okay, 2 more. I will see how much I can do today. If I cannot really finish that, what I would do is I'll turn them into tutorial example to show you. Okay, and then after the reading week, we have to start with the topics about object orientation. So since it's a reading week next week, I'll give you a little bit more videos to watch during the reading week, a little bit more just for your learning, okay? Anyway, let's see how much we can do. What if I cannot finish? I'll turn that into tutorial videos for you, so you don't lose anything. Let's see what the problem is and give you enough insight. Okay, that's about the maximum example we just talked about. Okay, hopefully you know how to do that. Okay, so this is what I want to talk about. This again is a very general problem to solve. Given an array of integers, I want to know either true or false. The answer I want to get from your program is very simple, either true or false. True if all the numbers in your array are positive. False if there's at least one number in your array that is negative, well, not positive, right? So that's, for example, let's give you a little bit more insight to see how we can automate the process using a loop. You always want to think about loop is simply a way to patternize what you have to repeat over and over again. Okay? If you identify the pattern, you can definitely use a loop. Let's see this. Let's say I simply got an array over here, simply numbers. Okay? The size is simply just 5. Okay? So you can see we got at least one number that is actually not positive. So that means in this case, we should really say false. Because not all the numbers are positive, right? Easy. So now let's just focus on this example. Don't even talk about just loop just yet. If I give you this concrete example over here, I want you to give me a Boolean expression to tell me whether all the elements in the array are positive or not. So I'm saying basically elements at position 0 should be positive, and element at position 1 should be positive, and all the way through to the last element should be also positive, right? So this is, let me say this. We got a Boolean variable here, conceptually, and then we say all positive, and this is kind of the answer you want to accumulate over in your program, okay? And then I'm simply using conjunction over here to say, I want the first number to be positive, I want the second number to be positive, I want the third one, fourth one, and fifth one, all the numbers to be positive, okay? That's how you would do for this particular example, okay? Now, for us as an engineer, we want to see how we can patternize this thing using a loop, okay? Number one, you can see the way the indices change, 0, 1, 2, 3, 4. You can definitely use a loop counter I. Agree? Okay? Now, the thing we haven't really seen so far is really this part here. You can see we're basically using the conjunction operator 1, 2, 3, and 4 times, basically, right? You can see that, right? So now how can we really try to incorporate this into the loop so that we can do it through the iteration? Okay? So now, once we get a loop, it doesn't quite matter how long the array is. The array can be of million numbers there for you to check. You don't have to write out a million conjunction over there. You can just use a loop. Okay? So that's kind of the insight I want you to get into. Okay? So now what I want to do is I want to show you the solution directly. Okay? Directly. Let's say we got this particular array. We got 2, 3, -1, 4, and 5. And we know that the result eventually should be false. Eventually, right? Okay? Let's say we got that example there. And now we have a Boolean variable over here. I simply say, so far, only positive numbers. Okay? I just have a number here, a Boolean variable. Eventually, I'm going to print out either true or false from this variable. Okay, the initial value over here is simply true. Let me just put a question mark over here. Oops. Thank you. Should be fine. Thank you. So now, the true value here, I will explain this part a little bit in the last step. Okay? Let's just take it for granted for now. Let's say we simply initialize that to be true for now. And then I want you to look at how we trace the code altogether. Okay? So I'm simply use a while loop. You can definitely convert that into a for loop very easily. So we simply say now, for integer I over here, simply initialize to be 0. The first iteration, I is going to be 0. When we check 0 less than ns.length would just be 5, right? 0 less than 5. That means we're going to execute this line here. Here is the critical part, okay? So now let me just say, so far we say this is simply just going to be true to begin with from line number 2. So I will simply put true over here, okay? Take this initial value as for granted just for now, okay? And then we are going to evaluate this line over here for the first time. I'll help you with the very first iteration. How does that check for this particular one? For the very first iteration, we simply got so far only positive numbers is assigned to so far only positive number, right? Exactly repeating itself, okay? Ampersand, ampersand. And then for the very first iteration, I is simply just 0 at position 0, larger than 0. Let's try to understand the very first iteration. That's the most crucial part, okay? How do we do this? Basically, we are trying to reassign the value for so far only positive number Boolean variable. But the way we reassign it, we have to use its current value before we reassign, right? So what's the current value for that? True, okay? And then what's the value for this particular expression? ns at position 0 is simply 2. So 2 larger than 0 is going to give you true. So true and true is going to give you true. So you can think about reassign that to just true. Okay? So now in this case, it's simply just going to be true for ns at position I larger than 0. Are we okay so far? Okay? Let's do the next iteration. Okay? The next iteration goes like this. So now if I'm going to use red. So now I is going to be incremented to 1. So 1 less than the size of the array, 5, is simply going to be true. We're going to evaluate this body of the loop for the second time. So what would that be? It's simply going to be so far only positive number is assigned to so far only positive number, ampersand, ampersand, ns at position. Now I value is simply 1. 1 is larger than 0. Okay? In this case, I at position 1 is simply going to be 3. 3 larger than 0 is going to give you true. And what's the current value for this Boolean variable? It's simply true over here. True and true is going to give you true. So that means you're still going to reassign this to be still true. Okay, so far so good, right? The next iteration is important because in the next iteration, we're simply just going to have -1, right? Let's try that together. I is incremented to 2. 2 less than 5, right? We're checking the state condition over here. It's just going to be true. So we're still going to evaluate this expression the same as before. Okay, I'll write it down. So far, only positive number is assigned to so far only positive number, ampersand, ampersand, a at position I, which is 2, larger than 0. Okay? So now when we evaluate this, A2 is -1. minus 1 larger than 0 is going to give you false, right? What's the current value for this variable here? True, right? So true and false is going to give you false. That means we're going to reassign it to false. So this is the iteration we're simply going to give you false over here. You can see the way we are going through this loop is we're trying to accumulate the conjunction over the iteration, right? That's what we're doing here. And one thing to note, you can see that as soon as the Boolean variable here becomes false, it does not quite matter to continue. Let me show you why. Let's go do one more iteration, okay? Now, if I do another one, so now you can see the current value for so far only positive number is simply false right now, right? So now let's say we move on to the fourth iteration. So we're going to consider another number over here, which is actually positive, right? Does it really matter? Is it going to rewrite the so far only positive number Boolean variable back to true? The answer is no. Let's see. So when i's value is simply 3, 3 less than 5, the length of the array is going to be true. So we're going to evaluate this particular body of the loop for the fourth time. Okay, I'm going to write it here. So that means so far only positive number is reassigned to itself, ampersand, ampersand, a at position I, in this case 3, larger than 0. Okay, it's now crucial to follow this. Okay, so now what about this part here? A3 larger than 0, A3 is exactly here. 5 larger than 0 is going to be true. However, does it really matter? Doesn't quite matter because the value for this particular Boolean variable from the previous iteration has been assigned to false already, which means this guy here is already false. Now, for conjunction, if one of the sides is already false, it will be false no matter what. So that means this will just be reassigned to false. Okay? So this remains to be false. So as soon as you see the very first number that is not positive, it's going to make this variable false. And it does not quite matter what you put after this particular position of the array. Okay? So this is the first version of the program I want to talk about. Questions? I saw somebody raise their hand. Are you okay with this version here? Okay? So for this particular discussion here, I plan to give you 4 different versions. Okay? And 4 different versions, one version out of the 4 doesn't quite work. Okay? So I would like to explain the logic over here, possibly in the tutorial video for the coming week. Okay? So that's very important for you to understand. Any questions? Let me say one more point and then we're done. So now let me revisit this particular initial value over here, which I said we should really take it for granted. Now think about this. There are only 2 possible values you can initialize this particular Boolean variable, right? Either true or false. I said true over here. What if, hypothetically, can I just simply make it false over here? Think about it. If I simply make this initial value for this Boolean variable simply false, is the program going to work? The answer is no. Because if the initial value for this Boolean variable is simply false, okay? So that means for the very first iteration of the loop, when we are trying to say whatever the current value for that Boolean variable is, which is false, and whatever the result is, it doesn't quite matter anymore because this value is already initialized to be false. So it wouldn't give you true ever. Okay? So now having false over here is simply not appropriate. So that's why it simply gets true. Okay? Well, I'm just trying to show you backwards. Now that we have seen how things work. Any questions? Okay, review this example here. It will be covering the tutorial video later. Okay, I'll see you after the reading week.